This is Dr. Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. In this session, I am going to discussing about lead-acid battery, construction, working principle, and applications. So, lead-acid battery is a best example for secondary cell. So, as we know, what is a primary battery and what is a secondary battery? So, battery in primary battery, it is nothing but non-rechargeable battery. So, if you take primary battery, we can observe only discharging process. Whereas in secondary battery, we can observe both discharging and recharging process. When battery act as discharging, it is a example for electrochemical cell. When during discharging process, battery act as a electrochemical cell, whereas during recharging process, battery can act as a electrolytic cell. So we know that what is a electrochemical cell and what is electrolytic cell and what is the difference between the electrochemical and electrolytic cell. So in the electrochemical cell, chemical energy convert into electrical energy. Whereas in electrolytic cell, electrical energy convert into chemical energy. So in secondary batteries, that is rechargeable batteries, we can observe both type of reactions, that is chemical energy to electrical energy and electrical energy to chemical energy. So during discharging process, we can observe conversion of chemical energy into electrical energy, whereas during recharging process, we can observe conversion of electrical energy into chemical energy. So here, lead-acid battery act as a secondary battery, since we can observe both type of reactions in lead-acid battery. So first, let us see the construction of lead-acid battery. Here is a small introduction about lead-acid battery. It is the oldest type of rechargeable battery, and it is invented by Gaston Plante in the year of 1859. It is classified as secondary battery. So, chemical reactions occurs in secondary cell are reversible. That is chemical to electrical energy, electrical to chemical energy. Lead-acid storage cell is the secondary battery, which can operate both voltaic cell as well as electrolytic cell. When it acts as a voltaic cell, it suppresses electrical energy and becomes turned on. When it recharges, the cell operates as a electrolytic cell. So coming to the construction, it is the construct. Let us see the construction of lead-acid battery. Here, lead plates and PbO2 plates are dipped in the electrolyte, that is H2SO4, aqueous H2SO4. So here, lead plates act as a anode and PbO2 act as a cathode. These plates are arranged in alternate manner. Here, electrolyte is aqueous H2SO4. These plates are separated by insulators and anode and cathodes are dipped into the electrolyte, that is aqueous H2SO4. This is a brief construction about lead acid battery. So, lead acid battery consists of a number of around 3 to 6 voltage cells connected in a series to get 6 to 12 volts of battery in each cell. So, here anode is lead and cathode is lead dioxide or grid made of lead packed with lead dioxide. A number of lead acid plates are connected in a parallel and number of lead acid plates also connected in a parallel way. These plates are separated by insulators like rubber or glass fiber. So entire combination is immersed in dilute H2SO4 having the density 1.3 gram per milliliter. So coming to the working. First lead acid battery act as a electrochemical cell. Electrochemical cell. So as we know, what is electrochemical cell? Here chemical energy is converted to electrical energy. Here chemical energy is nothing but reaction is initiated by H2SO4 which is act as an electrolyte in lead acid battery. Here H2SO4 is reaction is initiated by H2SO4 by using H2SO4 during discharging process. It supplies the some amount of electrical energy. So that is a discharging process. So in discharging process, lead acid battery acts as a electrochemical cell. Here chemical energy converted into electrical energy by using H2SO4. Let us see what is the reactions involved during discharging process. So here at anode in the sense lead act as a anode and PbO2 lead dioxide act as a cathode. So during discharging process at anode, lead is oxidized to Pb+2 which further combine with H2SO4 forms PbSO4. Okay, so before going to the reactions at anode and cathode, first H2SO4 that is electrolyte present in lead acid battery as a H plus HSO4 minus. Okay, this one. First H2SO4 dissociated into H plus SO4 minus. So we know that here anode is during discharging process, anode is Pb and cathode is PbO2. So during discharging process, H2SO4 first undergoes dissociation, forms H plus SO4 minus. So we know that oxidation takes place at anode. So red is converted into Pb+2 ions. These Pb+2 ions react with H2SO4 which is coming from H2SO4 during dissociation forms PbSO4 at the anode. So Pb plus 2 and SO4 minus 2 forms PbSO4 at the anode. So if you observe that here 2 electrons has been eliminated. So that's why we can say that oxidation reaction takes place at anode. So coming to the cathodic reaction. Here PbO2 acts as a cathode during discharging of lead acid battery. These PbO2 react with hydrogens of H2SO4 and one more SO4 is there. One SO4 react with Pb, another SO4 react with PbO2. By the gain of these electrons moves towards cathode. By taking these electrons, PbO2 is converted to PbSO4. Coming to the next cell reaction, PbO2 plus Pb in the presence of H2SO4 forms PbSO4 and H2O. So after discharging process, we can observe formation of PbSO4 at both electrodes. So initially Pb is the anode and PbO2 is the cathode. So after discharging process, anode is converted from Pb to PbSO4 and PbO2 also converted into PbSO4. So now after discharging process, both electrodes contains PbSO4. And one more important point also we have to remember. So during discharging process, formation of H2O also we can observe. So due to the formation of H2O, density of H2SO4 will be decreases. Then H2SO4 is completely consumed by chemical reaction, that is electrochemical reaction. So that is about discharging of lead acid battery. So during discharging process, chemical energy converted to electrical energy. That means reaction is initiated by H2SO4, which is act as a electrolyte. Then H2O also will be formed during discharging process. So due to the formation of H2O, density of H2SO4 will be passed down. Next, so from the above reaction, it is clear that PbSO4 is precipitated as at both electrodes and H2SO4 used up. As a result, in the concentration of H2SO4 decreases, as well as the density of H2SO4 falls below 1.2 grams per ml. In this condition, that means after discharging process, battery needs recharge. Then battery has to act as a electrolytic cell after discharging. So During electrolytic, due to recharging of battery, the cell can be charged by passing electrical current in the opposite direction. Then the electrode reaction gets reversed. As a result, Pb is deposited on the anode and PbO2 on the cathode. Again, the density of H2SO4 increases. So let us see the reactions of during recharging process. Now, during recharging process, your electrolyte is water, which is formed through the recharging process. So in first step, water dissociates into H plus 2O minus and 4H plus 4SO4 minus forms H2SO4. At anode, now what is anode? PbSO4. After discharging process, both electrodes are PbSO4. Anode is PbSO4 as well as carrier also PbSO4. So during recharging process, anode convert into Pb and PbSO4, that is a cathode, convert into PbO2. So let us see what is the anodic reaction and cathodic reaction during recharging process. So in first step, electrolyte, that is H2O. During recharging process, H2O acts as an electrolyte and H2O undergoes dissociation H plus and 2O2 minus and H plus SO4 forms H2SO4 at anode. PbSO4 undergoes reduction by the gain of electrons, forms Pb and SO4 minus 2. At cathode, PbSO4 plus 2 oxide ions forms PbO2 by the elimination of electrons. So coming to the next cell reaction, 2 molecules of PbSO4 react with 2 molecules of water, forms PbO2 and Pb and H2SO4. So we can observe that during recharging process, PbSO4, which is deposited at both electrodes, that is at anode and cathode, during recharging process, that is converted into PbO2 and Pb. And Pb is deposited at anode, PbO2 is deposited at cathode. And H2SO4, concentration of H2SO4 in a battery will be increases during recharging process. So that is the recharging of lead acid battery. During discharging process, concentration of H2SO4 was down. During recharging process, concentration of H2SO4 will be increases. So during discharging process, water will be formed. That same water consumed by during recharging process. So that is the recharging of lead acid battery. Next, coming to the what are the advantages and disadvantages of lead acid battery. It is made easily. That means arrangement of setup is very simple and compared to other batteries. And it produces very high current. The self-discharging rate is low when compared to the other rechargeable batteries. And it is also act as a effectively at low temperature. And coming to the disadvantages. Recycling of this battery causes some environmental hazards. Why? Because here we are using S2SO4 as a electrolyte. S2SO4 as a electrolyte. It is an acid and there is a chance to produce some hazardous nature to the environment. And mechanical strain and normal bumping reduces battery capacity. So these are the main disadvantages. And coming to the uses and applications. Usually lead acid battery used in automobiles. And it also used in gas engine, ignition, telephone exchanges, hospitals, and etc. These are also applications of lead acid battery. Material handling equipments. It is used in material handling equipments. Electrical bus using lead acid battery. And building UPS and different data centers. And solar plant and hybrids. And marine industry and trains. These are the types of lead acid battery. There are three types of lead acid batteries. That is fluoride battery and AGM, absorbent grass mat type of lead acid battery and gel lead acid battery. So among three batteries, there is no maintenance, zero maintenance for AGM and gel type of lead acid battery. And fluoride battery required some maintenance. So time to time, we had to change water. In case of first type of battery, that is fluoride battery. So these are the three types of batteries. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.